All right, it's recording. Your area formula to copy down to remember extra. Here we go. It's pi again times r again. So very similar to the circumference. The difference is it's not 2 times the radius. It is the radius squared. Now, the reason why students tend to forget this or confuse it is because when they read this, they say R2. R2 does not mean R squared. R2 can really mean R times 2. And that's why they're confused with 2R and R2. So to change your language, don't say R2. If you say R squared, you're more likely to do it right. And then the leftover bit, same thing again. Theta over 360. So that's the portion that belongs to the part of a circle. Sean, can you close the door for me, please? All right. This first bit is considered year 8 knowledge. Okay, so the first bit, pi r squared. So if someone asked you what is the area of a circle, you say pi r squared. That is the general knowledge for a year 8 student. This next component is technically a year 9, but really I'm teaching you because 4F has that one as well. Okay, so the year 9 component looks at partial circles, which I'll go through the notes in the next half. Okay, so what's this symbol? This symbol is called theta. And theta represents angle. Okay, so it's the angle of which you are focused on the circle. Are you looking at a full circle? Is it a full 360 rotation? So do you get a full circle? Or are you only getting part of a circle? So for example, if I only did this rotation, that's only 180 degrees. So 180 degrees out of 360, 180 over 360 is the same thing as what? What's 180 over 360? Half. That's why we say this is half a circle. That's why that formula is the angle that you rotate out of 360. So if you did a full circle, then it will be 360 out of 360. That's one full circle. This one is half a circle because it's 180 over 360. That's why we know it's half. Same thing with when I draw this diagram and I ask them what part of a circle, most students tell me it's a quarter. But then when I ask them, like, why is it a quarter? How do you know it's 1/4? And they're like, I don't know, I just look at it. But it's not that. It's the idea that this is, and they have to tell you this is 90 degrees. And then the logic to it is, well, it's 90 out of the 360. 90 out of 360 is 1/4. That's why we know it's 1/4. So the reason why it's important to know that this represents the angle of rotation is because in year 9, you don't get 90 and 180. You might get a shape that's like rotated, say, what's that? That's, say 168. So if it's 168 degrees, then it's 168 out of 360. Get me? Whereas this one was 90 out of 360. This is 180 out of 360. That's why you know it's half, a quarter, one full circle. Okay, so that's what that formula bit tells you. So how much of a circle do you want? That angle tells you how much rotation. Okay, so theta is the angle of the rotation. Okay, here we go. Let's do some problems now. So sometimes the question will ask you to do approximations. If they say approximations for pi, they have to tell you which one to use. So they'll say use 22/7 or they'll say use 3.14. If they don't tell you to approximate and you use 3.14, which is what a lot of students do, your answers could be wrong. Okay, so I want you to read the question. If the question doesn't say approximate, I don't want you to use 3.14. I actually want you on your calculator to find the symbol pi. Okay, and I'll show you why. I'll show you the reason why. Here we go. Let's do the first example. You've got the formula here. That's the formula we're going to be using. All right? Here we go. Let's do this question here. It says, find the area of the circle. So I've got a circle. And it says correct answer to 1 decimal place. Right? So first question is, area formula for a circle is pi times r squared, radius squared, not r2. Okay, so radius squared times, this is the part of the circle we want. Now, how much of a rotation am I doing to draw the circle? 360. So this is 360 rotation out of 360. So I want a full circle. What is the radius in this diagram though? 4. So then you'd say it's pi times 4 squared times 360 over 360. Now, grab out your calculator. I'm going to do it on screen so you can see why I don't want you to type 3.14. So this is what students do. This is what students do because they're too lazy to find the pi button or they don't know how to find the pi button. This is what they type. They do 3.14 times, now you said it's r squared, which is 4 squared. So it's 4 squared times, now some calculators, you can do a fraction template. Those green ones, the one that Sully's holding, you can press a fraction template to look like that. If you can't do a fraction template, say you're using the Google calculator, use brackets. Say, I want 360 over means divide. 360 over 360. That works as well. Okay, so that is the way to write a fraction. But if you can do a template, then it's easier to visualize it. So it just looks like 360 over 360. Okay, so if you can't do the fraction template, you can do 360 divide 360, but make sure to put a bracket around it. All right, let's see my answer. If you did 3.14, what do I get? 50.24. So it doesn't feel wrong. I did the calculations and I got 50.24. And it does say centimeters and it's area, so I write squared centimeters. Great. Here's the problem. Watch the difference between 3.14 versus if I actually use the symbol pi times 4 squared times 360 over 360. What's the difference? It's more accurate, but not only that. See, if we take the first digit, no problems. 50.2 is the same. As soon as you go to the second digit, 2.4 versus 2.6. Because you rounded this off, your area is always going to be slightly less than what the true value is. So at a year 12 level, which I actually got one of the foundation exams right here with me because I was going through it. You guys can have a look at it later too. Do you remember how I told you students next year, around this time, you guys are going to choose your subjects? And the students who float in high school, most of the time, if they struggle in maths from year 7 to year 10, they'll likely end up here in year 12. So I'm likely teaching this next year. That's why I went through the exam, just to see what it looks like. You know what's funny? These exams are not as easy as what the kids think it is. They're like, oh, I'll just do foundation and I'll get like a raw 50, which means getting top 2% in the state. It's not. All these questions here, maybe the first question was a ratios question. The next question was percentage error. I am so certain that most of the kids at that year 12 class that I'm going to see in the next 2 weeks, they're doing transition week, I'm pretty certain they don't know how to do this. And they think it's easy. It's not. Because you know what this exam really is? This is your year 7 to 10 maths content, but it's not just any average student, it's considering the top students. So think about all the top students in your current class. Whoever it is that you name, I can then give it to them. They should be able to do some of the questions or most of the questions, and there'll be some questions they won't know. Because that's the level at year 12, if you're doing foundation maths and you think it's easy, it ain't. That is also the same as VM numeracy. So if you think of doing a trade school, there is still percentages, budgeting, finance, maths that you need to know. This is the level. The only difference between foundation and VM maths, trade school versus doing a DC subject, one has tests, assignments, and exams, the other one doesn't. That's the only difference between them. But the content, you still need to know when you walk out that, get employed, people need to know, can you do fractions? Can you do percentages? Can you, bookkeep some salaries? Because they need to know that you can think logically. And that's all this exam is doing. But I went through it, and in only 2 hours, you know how many pages this is? It's 36 pages. You can grab it later. It's a very thick booklet. See, look at that. This is the exam that those kids who think foundation is easy, and I've got a full class next year, 26 students who think foundation is easy. They think they're going to cruise through, and I want to show them. Day one, I'm going to print this out and say, this is what you're doing. You chose this subject, and this is what you're committing to for 365 days or less, 3 terms worth. That's what you're going to sit down. And you think you're going to be top 2% just by coming to class, ain't happening. You're going to have to do work. That's how it is. at VCE. Okay, so if you're not thinking of studying, doing academics, doing tests, doing assignments, VCE is not for you because that's the requirement. That's what you've been doing since year 7 to 10. It's about doing homework, do study habits. We give you a bit to do this week and you take it home and you practice. That's what it is. When you get to VCE, we assume that you've got that skill and we just keep going. And you then have to keep up. If you don't keep up, you fail. Simple as that. Yeah? So, that one, and I'm pretty sure on this one, same thing. When they say correct to 2 decimal places, the kid who uses 3.14 will get this one wrong, and they will mark 0.26 correct. And it's interesting that what you're currently doing right now, there is actually a question I found in this booklet that I was doing. Question 10, look at the shape. Isn't that what you're doing in your exercises? It's a year 8 math skill. It's in a year 12 exam. Because as soon as you flip over, you start doing other stuff. Doing percentages, you're doing, you know how I talked about floor plans? Here we go. It's an application. Applies the areas into floor plans. Unit conversions, you need to convert area units. It's all there. So if you hated maths and you're thinking that by the time you get there, it's not going to come back, it does. It will all come back, you still need to know. So if you don't learn it now, you're going to have to learn it then. So that's why I say right now, you have the best time. This is the time where each week, I'm only doing 2 exercises. You go into this class, and most classes, you're doing more than 2 exercises per week. And if you can't keep up with that, well then, how are you getting your S? That's the difference. Yeah, so it's about commitment, it's about consistency, and all we're learning so far, it's one formula. So if you think about year 8, you've got 4 years before you get to year 12, which the students I'm going to take in the next few weeks. This is one of the things that they just need to know, which they would have learned 4 years ago. Yeah? Here we go. So what is the proper answer for this one? I don't want you to use, when they say find the area, if they don't say approximate, don't use 3.14 because that answer would be wrong in an exam. What you meant to write instead was the actual number 50.26548. So I'm going to write down 26548, round to 1 decimal place. So it should be 50.3 because that's the first decimal place. Next one's 5 or more. So then the answer should then be squared centimeters. Make sure to put the units. The examiners also ask for units. If you don't put it, they penalize you. So getting the correct decimal, correct units, that's 1 mark. Okay, so this one whole step is 1 marker because you get a calculator in the exam. Yeah? All right. Next question. See the difference between A and B? A was just to find the area. We still use the same formula. The difference is they now say approximate. So this time, you do not use the pi symbol, but you have to use 22 on 7. So here in your formula, same thing again. Instead of pi, we're now using 22 over 7 times the radius squared. And because this is a full circle, full rotation is 360 out of 360. So in your calculator, you should type 22 over 7 times, what's my radius in this case? 7 over 2. Very good. It's 7 over 2 squared times 360 over 360. So here there's a lot of fractions, so hopefully you're not going to type it wrong in your calculator. Try it out and see if you and I get the same answer or not. Here we go. I'm going to type it on my calculator. Fraction symbol, 22 over 7 times, that's my pi there, times, now 7 over 2. Let's say you can't do the fraction template. Bracket, 7, divide, 2, close brackets. That means the same thing. Okay, so 7 divided 2 means 7 over 2. To the power of 2 means squared, times, and again, I can do 360 divided by 360, which means 360 over 360. That line and this line are exactly the same. So if I press enter, you and I should get the same answer. Hands up if you got 38.5 on your calculator. Good. It means you entered correctly. Sounds trivial, but a lot of students don't know how to type that in a calculator. So here we go. That's 38.5. I'm not done. What am I missing? Units. Make sure to put in units. It's already rounded to 1 decimal place. Okay, so there we go. That's pretty much what you'll be mainly doing in exercise 4E. One formula. That's for full circles, but you might not get full circles. You might get half circles. You might get quarter circles. So let's try. Flip over the page. Let's do one where it's not a full circle. So flip over the page. So you get this one. What if you get half a circle? Well, let's say you didn't know it was half. But we know this is a straight line, so this has to be 180 degrees. That's rotation of 180. So from here, I have to go all the way around. That's 180 degrees. So here we go. Area formula for a circle. Recap. What's the area formula for a circle? Let's go with Hao-Xuan. Area of a circle was? Or is? It's on the front page. We literally just wrote these notes. Oh, you didn't write it down, did you? Ah, all right. Well, Leon then. All right, copy that down, Hao-Xuan. That was the first notes I asked you guys to copy down. So on the very front page, right there, that's all I asked. Pi times r squared. One formula, for God's sakes. One formula to copy down. Okay, it's just one formula for two exercises. Here we go. Pi times r squared times theta over 360. Here we go. Same thing again. This time they did say approximate, so make sure to use the symbol. Pi times. Be careful here. What's my radius here? Can I please have Wilbur? 6. Why isn't it 12? Let's go with Sully. Very good. So if you think about the full circle, 12 is from this point all the way to this point. That's the diameter, not the radius. So radius has to be half of it. That's why this is 6. And that's why this is 6. Okay, so it should be pi times 6 squared times. Now what's the angle? The angle of rotation is not 360 out of 360. It must be? Very good. 180 over 360. Type that in your calculator. Let's see what we get. Here we go. Pi times 6 squared times 180 over 360. Yeah, that should still be all right, but I'll just do it like this. 180 over 360, close brackets, and delete these brackets. All right, so we get 56.54866, 54866. And they didn't say round to any decimal places. Now, when they don't say, which means the test is pretty bad, but a proper exam and a proper test should actually tell you what to write at this point. Okay? Usually if you don't see it, especially from your junior levels, and if your teachers wrote this, then like me, round it to 2. That's your general safe bet. Don't round to 1. 2 is a better accuracy. 3 is too much. Okay? So round to 2. If you round this to 2, you'll get 56.55. Very good. What are we missing? Good. But we say squared kilometers. Very good. All right. So that is the example. That's, if you can understand what I just went through, that is pretty much most of the fluency skills from 4E. This is problem solving. I'm going to leave that for you to try, and I'll write up the solutions later. For now, flip over now to the 4F notes. So we're continuing with partial circles now. Yes, Will? Yes. What happened to your hand? 4F, go to 4F notes. Here we go. Yes. All right, part of the notes. So now you know the area formula for a circle. If you didn't copy it, it's right here. That's the formula. Theta is the angle of a circle or the rotation. Now there is a proper name for partial circles. What is a partial circle? It's something like, I don't actually finish the circle. That's a partial circle. Okay? So even, Pac-Man. You can even do this. That's a partial circle. You can even do a quarter of a circle. Well, let me do it again. Like this. This is all called a partial circle. But a proper name for it is called sector. So write that in. Partial circles are known as sectors, but there are 2 types of sectors that we differentiate. You see, when you find the areas, there's actually 2 areas. in that circle there? Can you see how I'm coloring one in blue, one in red? There's one big portion and one small portion. The big portion we call major sector, and the small portion we call minor sector. Okay, so when I ask you later, I might use the term, I might say, are we looking for a major sector or a minor sector? And all I'm asking is, are we looking for the bigger area or the smaller area? Bigger area has a bigger angle, the smaller area has a smaller angle. Yeah? What happens when you have exactly equal? Well, we just say semicircle. So we don't call it sector per se, we just say semicircle. Yeah? All right, so that's for terminologies. In terms of doing, it's pretty much what we've been doing so far. Let's do the first example. Formula is pi times radius squared times, and now you need to know which portion of the circle are you dealing with. So let's have a look at the portion of the circle. Here we go. I want not the entire circle, so not that full circle. Sorry, that's a bad shape. That's the full circle. I don't want the area of a full circle. I want the area of part of a circle. So this is the part that I want. What's the rotation in terms of angle from here to here? What's the angle? 140. Very good. So this is the minor sector. This is the major sector. So clearly, if this is 140, what's the angle on this side? 160. Whoa, not 160? 220. Okay, they have to add up to 360. So this is the angle for a major sector, but based on the shape, clearly we're working for the minor sector. So the area should be 140 over 360 and not 220 over 360. Let's write it out. Pi times, what's my radius in this case? 5, very good. It's clearly 5. From here to here is 5. So it's 5 squared times 140 over 360. And then we type that in our calculator. Okay, and that should give us the area of the partial circle. So the part that we want. We only want 140 of it. Okay, so here we go. Let's type it in the calculator. Pi times 5 squared times 140 over 360. You and I should get, hands up if you got the same, 30.543. You did? Good. Meant to get the same answer as me. So, should be 30.5432. Rounding to 1 decimal place, 30.5 squared centimeters. Okay? That's the first example, and that's 4F. So 4E and 4F are exactly the same. 4E has less partial circles, and 4F has more partial circles. If you two can't sit next to each other, move. Talking about you two. Okay? All right, let's try the next example. Let's try this one. What's the radius in this case? So it's pi times radius squared. So pi times, what's my radius? 7. So it should be 7 squared times, now you got to figure out the angle. What's the angle? Good. It shouldn't be 120. If you wrote 120, it is wrong because 120 is talking about this side. That's 120. What we want is this side, which is 240. So this is the area we want. So it should be 240 over 360. Type this on your calculator. And then you should get the correct answer. So just be careful with which region you're looking for. Is it the minor sector or is it the major sector? Okay, same thing. Pi times 7 squared times... The reason why I can type pi is because this is a senior calculator. So pi, the calculator knows it's pi. You guys actually have to type the symbol. 240 over 360. 102.625. So 102.6253. Round to 1 decimal place. Is 102.6 squared meters. And that is pretty much 4E and 4F. One formula, different shapes. Obviously, if you can do just the fluency, this is the fluency skills. Problem solving is the leftovers. Okay, so I'll write the solutions for the leftovers, but I want you to learn the fluency skill first. Okay, so usually question 2 to 5 is fluency, then you do problem solving, which looks more like these ones. Okay, so that's when you apply different shapes that you know, and you're working out for the remaining area. So this is problem solving, fluency. Learn this one first. Okay, that's it for today's lesson. I'm going to stop the video.